Hello everyone, this is Dnyaneshwar Sanap, working as an assistant professor in the Department of Chemistry at Maratha Vidya Prasarag Samaj, Arts, Commerce and Science College, Dillori. In this video lecture, we will discuss about the carbon dioxide molecular orbital energy level diagram, that is CO2. Basically, CO2 molecule is formed by the combination of one carbon atom and two oxygen atom. That is, this is triatomic molecule. Before going to the drawing of molecular orbital energy level diagram, first of all, let us understand how the molecule is formed according to the VBT. To understand how the molecule is formed, first of all, we have to understand the electronic configuration of carbon and oxygen atom. The electronic configuration for the carbon atom is 1s2 2, 2s2 and 2p2. Write this electronic configuration of carbon atom in the tabulated form in the excited state, that is 2s1 and 2p3. Similarly, the electronic configuration for the oxygen atom is 1s2 2s2 and 2p4. We can write this electronic configuration of oxygen atom in the tabulated form like this, 2s2 and 2p4. When this one electron of carbon atom is combined with the one electron of oxygen atom, similarly one electron of carbon atom is combined with the one electron of another oxygen atom, we get the two sigma bonds. And the remaining two electrons, when combined with the each oxygen atom single electron, we get the two pi bonds. And the structure of carbon dioxide molecule is like that. Carbon at the center point and both oxygen on the outer side with the linear geometry of carbon dioxide molecule. Out of these four bonds, the two bond is sigma bond and two bond is pi bond. This two sigma bond is formed by the combination of two carbon atomic orbital and one oxygen atomic orbitals together. Similarly, these two pi bonds are formed by using the two carbon atomic orbitals and one atomic orbital of each oxygen atom. Before start the actual drawing of molecular orbital diagram, first of all, we have to understand how these two sigma bonds and how these two pi bonds are formed on the basis of orbital presentation one by one. Let us see how the sigma bond is formed by the combination of carbon atomic orbital and oxygen atomic orbitals. The first formation of sigma bond between the carbon and oxygen by using the 2s atomic orbital of carbon atom and 2pz atomic orbital of both oxygen atom. S orbital is spherical in shape, but the p orbital of an z-axis is utilized for the formation of sigma bond, and the remaining px and py atomic orbitals does not take part in the bonding of formation of sigma bond. Let us see the diagrammatic representation. When 2s atomic orbital of carbon atom is combined with the 2pz atomic orbital of both oxygen atom along the z-axis, we get the combination of atomic orbitals like this. This darkened color indicates that the same sign wave functions are attracted towards each other, and there is formation of bonding molecular orbital between the 2s atomic orbital and 2pz atomic orbital along the z-axis. This axis is very important to understand the type of bond formed in the CO2 molecule. Then this same sign wave functions of atomic orbital combines together and it results in the formation of bonding molecular orbital along the z-axis, and it denoted by using the symbol sigma 2s. That is, the sigma bond is formed by using the 2s atomic orbital of carbon atom and 2pz atomic orbitals of oxygen atoms. Similarly, the formation of second sigma bond of carbon dioxide molecule by using the 2pz atomic orbital of an carbon atom and 2pz atomic orbitals of both oxygen atom. In first case, the 2s atomic orbital is used for the one sigma bond, and in second case, 2pz atomic orbital of carbon atom is used for the formation of sigma bond. That means the two sigma bonds is formed by using the different atomic orbitals from the carbon atom. When 2pz atomic orbital of carbon atom is combined with the 2pz atomic orbital of both oxygen atom along the z-axis, the pictorial representation like this. When these two wave function of same sign combines together, it result in the formation of bonding molecular orbital. Similarly, the other side, same wave function combines together, it results in the formation of bonding molecular orbital. That means the 2pz atomic orbital of carbon atom having combination with the one oxygen atom with the positive wave function and with other oxygen atom by using the negative wave function, and it results in formation of maximum bonding overlap, result in formation of bonding molecular orbital along the z-axis, and it denoted by using the sigma 2pz bonding molecular orbital. That means whatever bonding molecular orbital is formed by using the pz atomic orbital of an carbon atom. In both cases of formation of sigma bond, the difference is the carbon used the 2s atomic orbital for the one sigma bond formation, and carbon used the 2pz orbital for the formation of second sigma molecular orbitals. The next important formation is formation of sigma star antibonding molecular orbital in carbon dioxide molecule along the z-axis. First, the formation of sigma star molecular orbital by using the 2s atomic orbital of carbon atom and 2pz atomic orbitals of both oxygen atoms. When 2s atomic orbital and 2pz atomic orbitals with the opposite sign of wave function combines together, it resulted in the formation of two nodes perpendicular to the z-axis, and it denoted by using the symbol sigma star 2s. In formation of sigma star molecular orbital, the wave functions of both atomic orbitals are different from each other, and that's why there is no overlap, and it results in formation of antibonding molecular orbital. Similarly, the formation of sigma star molecular orbital or antibonding molecular orbital by using the 2pz atomic orbital of carbon and 2pz atomic orbitals of both oxygen atom. When 2pz atomic orbital of carbon atom is combined with the 2pz atomic orbital of both oxygen atoms with the opposite sign of wave function, it results in the formation of sigma star antibonding molecular orbital, and it denoted by sigma star 2pz antibonding molecular orbital. There is presence of two nodes between the pz atomic orbitals of between the carbon atom and both oxygen atom along the z-axis. The third important point is the formation of pi and pi star molecular orbital in CO2 molecule. Basically, pi molecular orbital is formed by using the only 2px or 2py orbitals of carbon and oxygen, because we utilized the 2pz atomic orbital for the formation of sigma bonding and antibonding molecular orbitals in CO2, and that's why the remaining 2px and 2py molecular orbital, which is perpendicular to the 2pz atomic orbitals, which is easily participate in the formation of pi bonds by lateral overlap, and that's why the pi bond formation by using the only 2px and 2py orbitals. Let us see first of all the formation of pi molecular orbital by using the 2px and 2py atomic orbitals of carbon and oxygens. We can consider the 2px atomic orbitals of carbon and both oxygen one time, or we can consider 2py atomic orbital of carbon and oxygen one time. That means we can consider the 2px atomic orbital or 2py atomic orbital of all three atoms at the one time only. Let us see how it works. We can write here 2p orbital for the 2px or 2py orbital commonly to avoid the confusion between the axes. When 2p orbital or 2px or 2py orbital of carbon atom is combined with the 2p orbital of both oxygen having same side laterally, it produces the pi 2px or pi 2py bonding molecular orbital. Similarly, the formation of pi star molecular orbital by using the 2px and 2py atomic orbital of carbon and oxygen is take place when 2p orbital of carbon atom is combined with the 2p orbital of oxygen atom, but during the combination the sign of wave functions are opposite, and it results in the formation of antibonding molecular orbital. In this overlap, there is formation of two nodes perpendicular to the z-axis, and this pi star antibonding molecular orbital generally denoted by using the symbol pi star 2px or pi star 2py, because it formed by using the px and py atomic orbitals. The next important point is formation of pi non-bonding molecular orbital in the CO2 molecule by using the 2px or 2py orbitals. Basically, the formation of pi non-bonding molecular orbitals take place when the bonding and anti-bonding effect of 2px or 2py orbital is mutually cancelled out. That is, it obtained by the zero overlap method. Let us see how it is possible. When 2p orbital, that is 2px or 2py orbitals of carbon atom is overlap with the 2p or 2px or 2py atomic orbital of one oxygen atom in the constructive phenomena, or when it overlap with the same side, it produces the bonding molecular orbital at the one side. And when same carbon atom 2px or 2py atomic orbital combined with the destructive phenomena and it produces the antibonding molecular orbital, it results in the formation of one node at the center of carbon atom, and it results in the formation of pi non-bonded to px and pi non-bonded to py molecular orbitals in the CO2. From this representation, the idea of how the bonding and antibonding molecular orbital in the CO2 molecule is formed is cleared out. Let us start the actual drawing of molecular orbital diagram for the CO2 molecule. To understand how the CO2 molecule is formed, first of all we have to understand the electronic configuration. Let us write the electronic configuration for the carbon atom. 1s2 2, 2s2 2 and 2p. Similarly, for the oxygen atom is 1s2 2, 2s2 2 and 2p 4. Write this electronic configuration of valence shell of both atoms in the tabulated form like this. Now let us start the drawing of molecular orbital energy level diagram for CO2 molecule. In molecular orbital drawing, we have to keep in mind the atom which is less electronegative among the combining atoms. We have to write on the left hand side in the increasing order of energy. On the left hand side, we write here the atomic orbitals of carbon atom in increasing order of energy. First of all, we write the 2s atomic orbital of carbon atom at the lower energy side or lower side and 2p atomic orbital at higher energy side. Similarly, we write the atomic orbital of more electronegative atom, that is oxygen atom, on the right hand side in the diagram. But during the writing of valence shell atomic orbital of both oxygen atoms, we have to write this 2s atomic orbital of both oxygen atom at very lower energy, because this 2s atomic orbital of oxygen atoms does not take part in the bonding, and that's why we write it at the bottom side for both atoms. First atom of oxygen and second atom of oxygen. This 2s atomic orbital of both oxygen atom is very low energetic, and that's why we write at the very lower energy or at the bottom side. The 2p atomic orbital of oxygen atom is right at the higher energy with respect to the 2s atomic orbital of oxygen atom, and the writing of 2p atomic orbital of one oxygen atom, and similarly we write the 2p atomic orbital for second oxygen atom. These two atomic orbitals of both oxygen atoms having the energy lower than that of 2p atomic orbital of carbon atom and higher than that of 2s atomic orbital of carbon atom. This lowest energy 2s atomic orbital of an oxygen atom of both oxygen atom does not take part in the bonding and keep as it is at the lower energy like this. But this 2px, 2py and 2pz atomic orbitals of oxygen atom first and oxygen atom second, that is A1 and A2, that is atom 1 and atom, combined with the atomic orbital of a carbon, that is 2s, and atomic orbital 2p, and it resultant formation of molecular orbital with the increasing order of energy like this. When 2p atomic orbitals of both oxygen atom is combined with the 2s atomic orbital and 2p atomic orbital, it produces 10 molecular orbital. Out of this 10 molecular orbital, 4 molecular orbital is bonding molecular orbital, 4 molecular orbital is antibonding molecular orbital, and 2 molecular orbital is non-bonding molecular orbital. As we see in the orbital presentation, when 2s atomic orbital of carbon atom is combined with the 2pz atomic orbital of one oxygen atom, it produces the sigma bonding molecular orbital and it denoted by using the symbol sigma 2s 2pz. Similarly, when 2pz atomic orbital of carbon atom is combined with the 2pz atomic orbital of other oxygen atom, and it results in formation of sigma bonding molecular orbital, and it represented by using the symbol sigma 2pz. The next, when 2px or 2py atomic orbitals of carbon atom is combined with the 2px or 2py atomic orbital of each oxygen atom, and it results in formation of pi 2px and pi 2py bonding molecular orbital. This two bonding molecular orbital is degenerate in energy. The next important non-bonding molecular orbital, which is produced by the combination of 2px or 2py atomic orbital of carbon with the 2px or 2py atomic orbital of oxygen atoms. That's why it denoted by using the symbol pi n 2px or pi n 2py non-bonding molecular orbital. The higher energy antibonding molecular orbital, which is formed by the combination of 2px and 2py atomic orbitals of carbon with the 2px and 2py atomic orbitals of oxygens with the opposite flow function sign, and it results in the formation of pi star 2px and pi star 2py antibonding molecular orbital. Similarly, when 2s atomic orbital of carbon is combined with the 2pz atomic orbital of an oxygen atom with the opposite sign of wave function, it results in the formation of sigma star antibonding molecular orbital, and it denoted by using the symbol sigma star 2s 2pz. Similarly, when 2pz atomic orbital of carbon atom when combined with the 2pz atomic orbital of other oxygen atom with the destructive phenomena, that is with the opposite sign of wave function, it results in the formation of sigma antibonding molecular orbital, and it denoted by using the symbol sigma star 2pz. This is complete picture of molecular orbital diagram for the CO2 molecule. The next part is filling of electron from atomic orbital into the molecular orbital with the increasing order of energy. Basically, this 2s atomic orbital for both oxygen atom is lower in energy, and both atomic orbital electrons are as it is kept at the lower energy like this. The remaining 12 electrons from the carbon and oxygen atomic orbital is filled in the molecular orbital of CO2 molecule in the increasing order of energy according to the above principle and Hun's law of maximum multiplicity. Let us see how this electron fill in the molecular orbitals one by one. The first two electron comes to the lowest energy sigma bonding molecular orbital, and it completely filled. After complete filling of sigma 2s 2pz molecular orbital, the third electron goes to the sigma 2pz bonding molecular orbital. The fifth electron comes to the pi 2px, and sixth electron comes to the pi 2py bonding molecular orbital separately, even it is degenerate in energy level, because according to the Hun's law of maximum multiplicity, there is no pairing of electron in any one of the molecular orbital till there is no at least one electron in each degenerate orbital. The next electron is get paired in the 2px and 2py orbital respectively, and it completely filled it. After that, the next electron goes to the pi non-bonding 2px and pi non-bonding 2py atomic orbital respectively. This degenerate non-bonding molecular orbitals get single electron in each according to the Hun's law of maximum multiplicity. After getting the one electron in each, the pairing of remaining electron one by one is take place in the non-bonding orbital. This is all about the filling of electron in the molecular orbital of CO2 molecule in the increasing order of energy. From this diagram, we are comes to the conclusion of the writing of electronic configuration for the molecular orbital in increasing order of energy. First of all, we have to keep in mind there is 1s atomic orbital in carbon as well as in oxygen atoms, and that's why we write here the K for the each atom in the electronic configuration to indicates there is electron which is not participate in the bonding. Let us write one by one. K 2s2 We write here 2s2 for the 2s atomic orbital of oxygen atom. This writing of 2s atomic orbital is not compulsory. you can write the sigma 2s 2pz raised to 2 directly. After that, sigma 2pz raised to 2. After that, pi 2px and pi 2py, which is degenerate in energy, and the number of electron in it on the parenthesis. After that, n 2px raised to 2 and n 2py raised to 2. That is, the electronic configuration is kk 2s to 2 2s to 2 sigma 2s 2pz raised to 2 sigma 2pz s to 2 pi 2px s to 2 is degenerate with pi 2py s to 2. n 2px to 2 is degenerate with the n 2py s to 2. The next important point is calculation of energy work during the formation of molecule. Basically, energy work is calculated by using the formula number of electron in bonding molecular orbital into minus beta plus number of electron in antibonding molecular orbital into plus beta. Let us put the value of number of electron in bonding molecular orbital and number of electron in antibonding molecular orbital. There are 8 electrons present in the bonding molecular orbital and no electron in antibonding molecular orbital. Put this value in the formula, we get an equation of 8 into minus beta plus 0 into plus beta. After solving this, we get the value of minus 8 beta, that is the stabilization energy. That means there is evolution of energy during the formation of CO2 molecule. The next important point is calculation of bond order. Basically, bond order is calculated by using the formula number of electron in bonding molecular orbital minus number of electron in antibonding molecular orbital divided by 2. We get the values of 4. That means there is formation of 4 bonds between the carbon and 2 oxygen atom during the formation of CO2 molecule. Out of this 4 bond, 2 bond is sigma bond that we discussed after starting the video, and 2 bond is pi bond out of these 4 bonds. The next important point is stability. On the basis of energy and bond order, we are conclude that there is formation of carbon-oxygen bonds and result in the formation of CO2 molecule. The next part is magnetic property. Basically, all electrons in the CO2 molecule are paired, and that's why the CO2 molecule is diamagnetic in nature. Thank you for watching.